morning, ladies and gentlemen, parents and students of all ages. I believe today is the 16th, it's a Thursday, and let's finish up our exponents. Now, you might see this and say, hey, Mr. K, what does it mean if you have exponent 0 exponent? Well, this isn't a 0. It's kind of smashed together so you might not see it, but those are really parentheses. So our first of two things we're going to tackle today is understanding what do we do if we have an exponent parentheses exponent. That's really the best way I could say that. Or a power raised to a power. Exponent raised to an exponent. Now that is going to have us doing multiplication. Let's get that into our heads right now. If I see exponent parentheses exponent, that means multiplication. This is not going to be the same thing as x to the a times x to the b, which gives us a plus b. Not the same thing. But this is just what I said, we multiply exponents on this. So let's tackle a few problems. Now, I've got 2x to the third power, all raised to the fourth power. Easiest way I can do this is to break this into two parts. This 4 affects both the x, and it affects the 2 as well. So that's 2 to the fourth, because originally, what's the power of that 2? Originally, it's 1. So you have 1 times 4, which is 4. 2 to the fourth times x. Now, we have to do 3 times 4, which gives us 12. Now, if you didn't have to simplify your answer, I would accept that. That'd be totally fine. But 2 to the fourth is 2, 4, 8, 16. It's all binary mathematics, kids. 16x to the fourth. And that is our answer for that. Alright, this one's set up a little bit different. Your exponent parentheses exponent only affects things that are inside the parentheses. So this -3 would go to this 6, but it would not go to this 4. This 4 is by itself because it's outside the exponent. So that is just 4 on the outside. What is -3 times 6? It's an 18, but a -18. That's right, good job, ladies and gentlemen. To the -18. Now, I really, really, really hope you guys see what's the difference between these two. One, where we had a number inside the parentheses, the other where we had a number on the outside the parentheses. Now, I want us to simplify, so I don't want to see this -18 unless it says, hey, write your answers with negative exponents. So what do we do with a negative exponent? We put it in the denominator, that's right. So this is 4 over x to the 18th power. Now that's a super big power, but it's a very small value because it's in the denominator. I'm not even going to give a situation because I would have to raise something to the 18th power, and that does not sound fun to me. But check for understanding. Now, ladies and gentlemen, this one looks super complicated, but take it step by step. Pause the video, try to simplify this expression. You've got 1 power, 2 power, and then third power that you have to deal with. So once again, pause the video, take 5 seconds, work on it on your own. Got my handy dandy watch. Love it. My wife gave it to me for Christmas 2 Christmases ago. Works great. And so, first thing I do is I notice that this 2 is not within this parentheses. So this 2, as I'm going to change my color to red, only affects the x. So at first glance, I have 2x squared. because the original power of that x is 1, so 1 times 2, 2. Then I see this negative 3, and that's not the best color. I'll still work with it. At this point, both the 2 and the x are inside the parentheses, so this negative 3 would affect the x and the 2. So that gives me 2 to the negative 3 power x. What's 2 times negative 3? Negative 6. Good job, ladies and gentlemen. And so we first had 2x squared, then it's now 2 to the negative 3rd power, x to the negative 6th power. Let's move on to another color, blue for Manassas. And so now I've got this negative 4. Same thing as with the negative 3. It's going to affect the 2, and it's going to affect the x. So what's negative 3 times negative 4? Well, negative times negative is positive, and that's going to give me a 12. So I end up with 2 to the 12th power. And same thing, what's negative 6 times negative 6 times a negative 4? Negative times negative is positive. 6 times 4 is a 24. So this is 2 to the 12th power, x to the 24th power. Now, ladies and gentlemen, when you simplify this, please, 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 please don't say that, oh, 2 to the 12th power is 24. That's not 2 to the 12th power. That's 2 times 12. Instead, you have to do 2 times 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 2. That's a lot of 2's. But if you did it all correct, it should be 4,096 x to the 24th, and that'll be your final answer. Now, ladies and gentlemen, that's gone from 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, and 4096. So yes, 2 to the 12th power should be 4096. Now, let me get this out of the way. Sorry for that pop up. So, we've covered all the main exponent rules. I might take some time next week and dig through to find some more obscure ones, but adding, subtracting, and multiplying exponents are essentially all that you're going to be dealing with when you're in Algebra 2, and if you have a good grasp on those, you can tackle any of the other exponent ones without much problems. So, for the final one, I just wanted, for our final section on this, because we're going to do something a bit different tomorrow, I want us to be able to put all that stuff together. If you can put all your exponent rules together and shift between each rule quickly, then that's the best thing you could do. So, let me see. There we go. First and foremost, let's put this all together. If you have two variables and you're multiplying two variables or two numbers, you add exponents. You add exponents. So if you give me two letters, well, actually give me two of the same letter. Let's go with W's. Now, let's go with S's. So if I have S and another S, and it's times S to the 10th power and S to the 11th power, well, that's going to be S to the 10 plus 11, and that is S to the 21. Now, the converse, if I'm saying that correctly, I might just want to be saying the opposite, but I think it's the converse. The other direction is true. If I divide variables, Oh, it's early in the morning, kids. Well, it's early for me. No, it's really not early. Besides the point. If you divide variables, you subtract the exponents. So let's actually deal with just straight numbers this time. Let's go with something, I don't know, like 8 to the 7th power divided by 8 to the 3rd power. Since they're the same base, well, you can just say that's 8 to the 7 minus 3. Oh, that's 8 to the 4th power. Don't ask me what 8 to the 4th power is. 8, 64, it's 64, it'd be 64 squared, I'm pretty sure. Yeah, it doesn't matter. 64 squared, maybe if we have some leftover time, I'll try to tackle that. And what we just did today, if you have an exponent raised to an exponent, you multiply exponents. We just did that one. I shouldn't have to do an example again, but your example is essentially there. If you have e parentheses f, well, that's e times f. And so let's tackle a problem. Now this one is a bit complicated because it's incorporating all 3 rules at once. But if you tackle the problem, wow, please excuse me. Oh, I thought I got enough sleep last night. If you tackle all 3 problems at the same time, you might get a little bogged down. Do it small steps at a time. First, tackle the multiplication, then tackle the division, then do the exponent. So, x times x, I'm going to add exponents, right? Well, what's 3 plus 9? That's going to give me x to the 12th divided by x to the 7th. Alright? Oh, and let me finish up the whole problem. At this stage, do the division. We know what division does. We have it right here. We subtract, and so that's going to be x to the 12 minus 7, all raised to the 12th. And what's 12 minus 7? It's 5. So that's x to the 5th raised to the 12th. And we multiply exponents, right? Well, what's 5 times 12? 6 to the 60th power. And you're done. That's all you need to do. So, I wanted an actual challenging check for understanding. So if you need a breather, take a moment now, pause the video, breathe. Because, ladies and gentlemen, your final question is a little different. Interpret the statement. Meaning, take this, write out whatever expression or equation that they're asking you to, and then simplify it. I'll give you 5 seconds. Alright. The variable w raised to the 7th power. So whatever I have, it's raised to the 7th power. Divided, okay, well that's easy enough, divided by the product, so whatever I have down here, product means multiplication, I've got a multiplication down here, of w raised to the 3rd power and w to the 9th power. Good, I'm all using the same variable, which is easier, means I can actually do things. One's raised to the 3rd, and the other one's raised to the 9th. And all raised to a negative 2nd power. Well, that looks pretty much exactly like the problem we just had, except we have a product on the bottom. So do that product first. W to the 7th, and this is a w. Now, 3 plus 9 is 12. Did I write the same problem? So that's the point. Negative 2 And then I have W7 minus 12. I think I wrote the same bloody problem. Anyways, besides the point. W to the negative fifth. And ladies and gentlemen, this is a bad parentheses. What's a negative 5 times a negative 2? It's W to the 10th. So, ladies and gentlemen, I believe I said it earlier, we're going to tackle something different tomorrow. Because a lot of parents and teachers are having some difficulties getting into Microsoft Teams to have the students be able to see their work. Instead, for tomorrow, my lesson's going to be just kind of a visual how-to of getting into Microsoft Teams. I'll cover the desktop version, but if you have a phone or something and you download Microsoft Teams, I think it's even easier. The steps are roughly the same. So our answer for this is going to be W to the 10th power. Tomorrow we're going to talk about Microsoft Teams. I hope you guys have yourself a wonderful Thursday. Stay safe, stay inside, wait for it to blow over. Have a good day.